Hi everyone, here's another one. I love it. I'm going to post these as separate questions and keep my videos a little bit smaller. That way I think I won't have as many issues trying to save and upload and download. So let's do this one. This is actually a multi-component question. It's a synthesis question, but I love it because we just had a synthesis video. So let's take those skills and let's do each one of these, and let's worry about our functional group. Oh, that was the sparkle pen. That's a fun. All right, so let's worry about our functional groups, and let's do some numbering. And we're looking for that. Oh, that's not a no, that's a number. So we're looking for spacing. We're looking to give some piece of information to tell what kind of reaction we need to do that transformation. And then we're also looking at, okay, we're going to start with our functional groups, and then we're going to picture, hey, let's just try and challenge ourselves. Let's just go one step backwards. Just one step backwards. That's it. Okay. So I think if we're trying that, then we should be in business. This is a nice question with a couple step synthesis for each one of these. And so I think it's going to give us a nice test review. So let me erase this and let's give ourselves some space. Let's tackle this first one. All right, the first thing I noticed for each one of these is that we need to start from cyclohexanone. Okay, we did that in our last synthesis. It's a common starting material for me. And then let's take a look at this first one, letter A. And let's look at our spacing. We've got two different functional groups in here. We've got an ether. Oh, hello, Unit 2. Didn't we actually look at ethers in Unit 2? We did, so we may have to grab your cheat sheet from Unit 2. We're going to need it. And then we also have an alkene. Okay, we've seen those twice now. We've seen those in Unit 2, dehydrating an alcohol, and we've seen them now in Unit 3, after heat and an aldol. Okay, and then of course, let's add some numbering. Let's look at our spacing for that. So if we start with our oxygen, 1, 2, 3. Okay, now hang on a second. That alkene for an aldol, where does it end up? Doesn't it end up between 2 and 3 always? So actually, what do you think about this numbering, 1, 2, 3? Even though this doesn't quite look like an aldol yet, doesn't this have the spacing for an aldol? It does. So let's see if we can't picture this reaction with an aldol in mind. And let's see if we can challenge ourselves. I don't know why my screen keeps going down. I'm sorry, y'all. I'm still new at this. All right, so let's see if we can challenge ourselves to just go one step backwards. And I'm going to help you out with this one, and I'm going to grab my info from ether from Unit 2, because if we're picturing an aldol, we don't have an ether and an aldol at all. And if aldol is going to be one of our major reactions, then maybe we ought to take care of that ether first. So let's go one step backwards. How do we make an ether? Well, for this one, if we take a look at that methyl, isn't that primary? That is primary. So what kind of ether reaction are we looking at? Williamson ether synthesis. So let me help you go one step backwards. What if what we really start with is this? Okay. All right, now this is getting a little bit more recognizable for our aldol. And now how would we go forward for a Williamson ether synthesis? Well, we just need sodium hydride and methyl bromide. And that would go forward for that one. Okay. And now let's keep our numbers going. Our aldol, 1, 2, 3. And how did I know the 2 and the 3? Well, remember, that's where we form that bond. Except what functional group do we need for that number 1? Number 1 never ends up as an alcohol. what does number 1 end up as? Let's go one step backwards from this. Let's just picture one step backwards here. Again, if this were an aldol, what would number 1 have to be? It would have to be an aldehyde or a ketone. Okay, now we're getting somewhere, and can't we recognize this as an aldol? Doesn't that look like an aldol? 1, 2, 3. We are going to form the bond right there. So what would be the pieces for this one as an aldol? Well, we always form the bond between 2 and 3. Remember 1 and 2, this is our cyclohexanone, but as the enol. That's our 1, 2. And then what would number 3 be? Well, if it's helpful, we can draw it like this. It is totally okay to give yourself some help and write in that that would have been an OH there on your 1, 2, 3. So then if this is the bond we make, what are those two pieces? Well, then you're going to have your enol here, this enol, and then what is your actual number 3 going to be? How about that? All right, so these are our two partners then for that aldol. And then how do we go from here to here? Heat. So that's actually just one step, and we'll turn right around and write that out forward. And then how do we go from a ketone to an alcohol? That was unit 2. Something nice like sodium borohydride or LAH, I would take either one. And then our Williamson ether synthesis. Okay, so that was super fun. That was a nice combo of unit 3 and unit 2. Okay, now my screen is crazy messy. So let's actually just scroll down and write what that would look like forward. We would take our cyclohexanone and here. Okay, but remember, we add these two together, and holy crap, don't we have 6 or 7 or 10 or 12? How many? Holy crap, do we want to do this as a mixed aldol? Oh, Sal, no. No, we can't do that. We need to do this as a directed aldol. Okay, what's the difference? It means we're going to use base and add them in order. So which one do we need to be our nucleophile? We need this to be our nucleophile. We need this to be our electrophile. Okay, our numbering means 1, 2, 3. So that means which one do you treat with base? We're going to treat this one with base. And then we're going to add our number 3. And then we're going to quench. And then, in our quench, we're going to heat it. Okay, so that is literally all one step in synthesis. And we just went all the way to that. Holy crap, one step. All right, then we're going to reduce it. Maybe sodium borohydride. And then that would give us that alcohol. Remember, sodium borohydride doesn't do anything to your alkene. And then we're going to do our Williamson ether synthesis. So we would add sodium hydride, and we're adding a methyl, and that would give us our product. So that whole synthesis, I love it, is 3 steps. 3 steps. That's it. I love it. So that's for the first one. All right, let me pause for a second if you need to. I'm going to erase the screen, and let's tackle B. Okay. All right, this is going to be so much fun. I'm still getting used to the little eraser on here. And for some reason, my screen doesn't move unless I'm in I don't know why. All right, let's tackle B. Okay, this is super exciting. All right, let's go and let's number. We have only one functional group. There's really nothing to number. What we could do is mark a number 1 right here. If we're starting from cyclohexanol, look at that. Okay. All right, this was in our last video. This is super exciting. I hope you're in your mind already. You can already spot the reaction we're going to need to do here. What's our favorite old German phosphorus chemistry? Let's sparkle pen. I am thinking Wittig for this one. Remember, how do we spot a Wittig? Literally, you're replacing that ketone with a double bond. So this one's going to be really fun. We can even draw it forward already. Let's start with our cyclohexanol. And then what would we add for that Wittig reagent? Let's count our carbons. We need a 2-carbon unit. So we would need this ylide. And here's our 1 2-carbon unit. So how do we write this as a synthesis? We would start going forward from the alkyl halide. Number 1, we'd add that triphenylphosphine. Number 2, N-butylate. Let's make the ylide. Number 3, add your cyclohexanone. Boy, that's a bad drawing. Okay, and then that would give us our product. One step. I love it. All right, let me pause for a second and erase. And then let's tackle C. Okay, C is going to be really fun. Now, there's some chemistry coming up in Unit 4 that's going to do C just a little bit easier for us, but I still want to do C even if it takes us a couple steps and we may have to use 1 or 2 OChem 1 reactions, but we'll completely redo C in our next unit and see that we can make it even quicker. So let's go ahead and take C. All right, we've got a couple of ways we can do this. We have a cyclohexanone. We can picture that cyclohexanone here, or we could picture it here. We could do either one. Now, in our next unit, I'll tell you that this is the one we're going to pick. In this unit, let's pick this one. It's going to be a good review. All right, so if we imagine that our ketone was here, and now let's look at our spacing. Our spacing is 1, 2, 1, 2 for each side of that cyclohexanone. So is this an aldol? No. Aldol is 1, 2, 3. This is going to have to be some enolate chemistry right there. All right, so let's go one step backwards then. From here, let's add 1. Let's just add 1. So how do we actually add those? Well, remember for our enolate chemistry, in fact, let's add both of them. This is straight out of your notes. We did this in class. We just happened to do it with a methyl. So this is in your notes. So how do we add those 2 ethyls? We choose wisely on our base, and then we add ethyl bromide. And there's our 1, 2. There's our ethyl groups there. So what do I mean choose wisely on our base? Well, let me write that out going forward. Okay, if we take cyclohexanone and we add sodium hydroxide, both sides are the same, it is not going to matter. Now we have to be very careful and add only 1 equivalent of that ethyl bromide. What happens if we add excess? That was our last synthesis question, and we ended up with 2 of them, but we ended up with them on the same carbon. We don't want to do that for this one. So we're going to have to do this in 2 steps. We need to use our huge base for the second step and add our ethyl bromide. Now this time we can substitute on the other side. And again, we just need one equivalent there of those two. Okay, now the question becomes, how do you get rid of this? Well, I can't think of an elegant way to do it without using just a little bit of OChem 1. I will tell you that there's a named reaction in the next unit that will get rid of a ketone. It just doesn't happen to be in this unit yet. So it's going to be a little stepwise. We know that we can reduce it, sodium borohydride. And why did I reduce it? Well, if we have the alcohol, we learned in Unit 2 that we can use a little bit of acid and we can form the alkene. Now this is one step then from OChem 1. Do you remember how to add hydrogen to it? Oh, to an alkene. I can't draw right there. There we go. And we can use hydrogen and palladium. Again, not so elegant. We will use a Wolff-Kishner in our later reactions. We'll see a Wolff-Kishner pop up for that. All right, let me pause and erase again, and let's tackle D. I think these are kind of fun. You've got some of this in your homework and other practice tests. I always have a question like this somewhere on an exam. Just couple step synthesis, just make sure we're on the same page, recognizing those reactions and recognizing those functional groups. All right, so let's look at D. There are a couple ways of actually tackling D. D might get a little bit easier in our next unit. But, you know, I could envision a couple things. What if we pictured that we were coming from an aldol? Could this be an aldol? If it was, we'd have to go this way. Or could we envision an aldol the other way? Let's see. Could we envision an aldol maybe this way? 1, 2, 3. If we form the bond between 2 and 3 here, that's going to be pretty hard to do. What if we envision this kind of an aldol? Well, then your number 3 is going to be an OH instead. We could maybe do that. Boy, we'd have to really mess around and try to get rid of those oxygens though, right? I'm thinking we would need some protecting groups there. So could you choose this way? Yeah, you could. It's going to be pretty long. Could we do something else? Could we do some kind of alkylation there and have this add into that number 2 and leave ourselves something there? Maybe. Could we actually do a Wittig? Yeah, maybe. Why not? What if we go from this compound to this compound? We already know how to make this one. I'm sorry, I just totally screwed that up. What if we go from this compound to this compound? Could we do that? Well, we have a 2-carbon unit there, 1, 2. Yeah, I think we could. We'd have to do some OChem 1 chemistry and some Unit 2 chemistry. So we'd have to take that and we'd have to go backwards. This would be Unit 2. And we'd have to make the alcohol. So we'd have to use sulfuric and water, except we probably wouldn't make that alcohol. We'd have to use HBr, H2O2 from organic 1 to make that alcohol. Or actually that would make the bromide. We would need, my screen is frozen. Y'all, in the big picture, this actual test question is coming on our next test. We will learn how to make that quite readily on our next test. You can see just from my spitballing that we can't actually get to that pretty quickly. You know, as soon as we start messing around, we're hitting stuff from OChem 1, we're hitting Unit 2, but it doesn't really work the right way. We could picture BH3 here. Maybe BH3 would give us the right alcohol, and then we could do a Jones. So we could make it happen. It would be pretty ugly. You know, why don't I write that out real quick? What if we treat this with BH3 from OChem 1? Now we're going to make that. And then what if we treat, I keep drawn to the starting material and not the product. What if we treat that with Jones? We could do that. So we could make it happen. It's just not very elegant. That question will pop up again for us in our next unit. All right, I hope this gave you something to think about. I'm going to stop here so I don't get too long.